In today's lesson, we'll be learning about scatterplots. Take a look at the picture of the skateboard ramp and skateboarder. If you start at the top of the ramp, you'll be going pretty fast. But if you start at the bottom of the ramp, you'll be going much slower. Therefore, you can probably say the higher you are on the ramp, the faster you'll go. As you can see, I've represented the situation with a scatterplot. On the x-axis is your initial height in meters, and on the y-axis is your speed in meters per second. As predicted, the higher you start, the faster you'll go. I've gone ahead and drawn a line of best fit. Remember, a line of best fit is a straight line. It is drawn through most of your points, or you can have an equal number of points above or below the line. Remember, this doesn't have to be perfect. It is just an approximation. This line of best fit can be used to interpolate, extrapolate, and to spot outliers. Let's begin by interpolating. Remember, interpolating refers to making a prediction between what you already know. Let's say I want to know what the speed is when the skateboarder has an initial height of 3 meters. Using my line of best fit, I can predict that the speed is about 5.2 or 5.3. Next, I'm going to use my line of best fit to extrapolate. Remember, extrapolating refers to making a prediction beyond or outside of what you already know. Let's say I want to find the speed when the skateboarder has an initial height of 1 meter. First, I'm going to extend the line of best fit. Then I'm going to use it to predict the speed, and it looks to be around 3.7. Finally, we're going to look for outliers. Remember, outliers sound like outsiders. Now take a look at the blue points. Is there anything that looks out of place? This point right over here looks out of place, making it an outlier. This outlier could be here for any number of reasons. It could have been a fluke. This information could have been recorded improperly. We're not really going to discuss those reasons in this lesson. Our scatterplot can be described in terms of type, direction, and strength. We're going to look at type first. Look at the blue points. Do they resemble a line or do they not resemble a line? I would say they do resemble a line, making them linear. Therefore, this is a linear relationship. Next, we're going to take a look at direction. Generally speaking, are these points going upwards or are they going downwards? I would say they're mostly going upwards, giving it a positive direction. Last, we're going to take a look at strength. Strength refers to how close the points are to the line of best fit. I would say these points are pretty close to the line of best fit, making it a strong relationship. Now I know there's an outlier over here, but if you ignore it, it looks pretty strong.